Okay, let's go ahead and solve some of the Bohr and Lewis diagrams. And we have the hydrogen atom, and we know that that number equals the number of electrons, and it also equals the number of protons. Now for the neutrons, you would have to do a little subtraction, and that equals to 0. Okay, now let's take a look at how many electrons do we have. We have 1 there, and we have 1 for the Lewis, and this is the Bohr diagram. I'm gonna take these out because you're not gonna use any more than just one orbit. Okay, let's go ahead and do the next one. Now for this one, we have that equals the number of electrons, which also equals the number of protons. Neutrons would be 4 minus 2. Okay, and that's 4 minus 2, and now we have 2. We're gonna go ahead and put the electrons on here, and we have 2 electrons. And for helium, the Lewis structure would look something like that. It's gonna take away the 2 other orbitals that we don't need, and it should look like that. Lithium, once again, that equals the number of electrons equals the number of protons. We are putting the electrons on the Bohr diagram, but let me give you the number of neutrons. For lithium, you would have 4. Okay, why? Because you subtract that one, which is the mass, minus the atomic number. Okay, to get neutrons. Okay, on the Bohr diagram, you're gonna go ahead and put the electrons. So we have 1, 2, and then we have to jump into the other orbit because we don't have room in the first orbit. You can only fit 2 in the first orbit, in the first circle. Now for the Lewis, you would have to put 1 dot. Why? Because there's only 1 valence electron. Okay, that's the Lewis. And you have 1 valence electron. Okay, for beryllium, once again, we're gonna have, those are electrons. Okay, for neutrons, we have 9 minus 4, and that's gonna be 5. And we're gonna go ahead and place the electrons on here. 1, 2, 3, 4. Okay, so I'm gonna take this one away, and we're gonna place the valence electrons on here. Okay. For boron, we have, that would be the number of electrons. Okay, and we're gonna go ahead and place them into the Bohr diagram. That's 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. And we're gonna go ahead and take away this one. We don't need it. We don't need that one. Let's put the valence electrons. We only have 3. Okay, Take a look at that. That's that. All right. Neutrons for this one, we have 6. For carbon, once again, that is the number of electrons. We're going to go ahead and place them 1, 2, 3, 4, 5, 6. Let's take away that one. We didn't need the third orbit. And we're going to go ahead and place the valence electrons on the Lewis structure. Okay. For nitrogen, number of electrons, 7. Neutrons equals to 7. Okay, let's go ahead and put that. 1, 2, 3, 4, 5, 6. And we're going to pair one up. 7. Let me go ahead and take away the third one. We didn't need the third orbital. Okay, and let's go ahead and put the valence electrons on the Lewis structure. 1, 2, 3, 4, 5. Oxygen has 8 electrons. Okay, let's go ahead and put them on here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's go ahead and erase this orbital. We didn't need that shell. And let's place the valence electrons. 1, 2, 3, 4, 5, and 6. All right, let's go ahead and do this one. That would equals to the number of electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll take away that one. We don't need the third shell. Let's go ahead and put the valence electrons on fluorine. 1, 2, 3, 4, 5, 6, 7. 7 valence electrons. Okay, so 7 valence electrons, and those are the on the outer shell. Okay, that is equal to the number of electrons. We're gonna go ahead and place them. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right, let me take this out. If you notice, this second shell is complete, and that makes it a noble gas. It's very, very stable. It's pretty happy with what it has. It has a full shell. Okay. Up to 8. All right. Okay, so now we're in the third period of the periodic table. And if you notice, we have sodium right here. And sodium has 11 electrons. So let's put them on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we need one more right here. 11. So we're going to go ahead and put the valence electron. There's only one in the outer shell. And notice we are in the third period and we have 3 shells. Okay, for magnesium, we have 12. So we're going to place them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We definitely have those full. And now we need 2 more. 1 and 2, and if you count all the dots, you get 12. And we're just gonna go ahead and put the Lewis structure, and there's 2 in the outer. You see 2 electrons on the outer shell. Okay. Neutrons, remember 24 minus 12, and for magnesium it's gonna be neutrons equal to 12. Aluminum, let's go ahead. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 1, 2, 3, and this is a Lewis. Okay, this is a Bohr. And for neutrons, in aluminum we have 14. Silicone, this one equals the electrons, and we have 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 13, and 14. Okay, so if you take a look at that, we have 4 valence electrons. All right, and neutrons, just so that you know, silicon has 14. Why? Because you take away 28 minus 14. Phosphorus, okay, those are the amount of electrons. Neutrons, we have 16. Remember, you take away 31 minus 15, the mass minus the atomic number. Let's go ahead and put the electrons on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So we have 2 over here, 1 over here, and 1 down there. You have 5 valence electrons. Silicon. Okay, let's see. Let's go ahead and put them on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, we have 6 valence electrons because they're in the outer shell. And for silicon, the neutrons would be 14. Chlorine. Chlorine has 18 neutrons. And we're going to go ahead and place the valence electrons, 17 of them. The electrons on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And we are only 1 short of completing the shell. And finally, argon. And we're going to go ahead. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. And that means that this one is a noble gas, very stable type of element. It doesn't react, pretty much is happy with what it has. Once again, that's number of electrons, and the neutrons in this case would be 40 minus 18, and we have neutrons equal 22. Okay, I hope you will get it now, and if you have any other questions, you can post any comments and I'll try to clarify it. Hopefully you have noticed a trend here, and that was the purpose of our activity in class. All right, thank you for watching. Bye.